Okay, so this is the first video for our Algebra 1 course. This is our first video of the kind of review and refresher and getting ready for Algebra 1 section, our Unit 0, if you will. Now, if it's the first video, why is it called 0.2? Well, it's because in the textbook I'm using in my classes right now, this is the second lesson. So right now I'm matching these. When I eventually remake all these videos and whatever else in the future and all the other things and whatever, then this will probably be 0.1. But for now, it's 0.2. So we're going to talk about real numbers. We're going to talk about what I like to call the real number amoeba. You'll see why in a minute. And if you've been in my classes before, you probably have seen this, or well, maybe not the entire thing, but you've seen parts of this. Where this is the amoeba in its final form, its biggest stage, whatever. All that. I didn't ever do Pokemon, and I don't remember what Digimon well enough. So anyway, most people watching this video are too young to know. Well, I don't know. Anyway, I know I'm rambling a lot on this video. It's going to be a pretty straightforward one. We're also going to sneak in some not prime numbers, well, you'll see in a minute. So we're going to talk about numbers and different types of numbers. We're going to look at the smallest set of numbers, and we're going to kind of build that up into this big super set of numbers called the real numbers. So when you were way back and you were in grade school and in kindergarten and all of that kind of stuff, you learned you learned about a set of numbers called the natural numbers. Now, you probably didn't call them that. If you called them anything, you called the natural numbers the counting numbers. So natural numbers are things like 1, 2, 3, etc. Right? And so that's your basics. That's right. That's more. So that's this kind of the smallest, our base level of numbers. Okay, is the natural numbers. Then pretty quickly after, you learned about the next set, which is actually almost the exact same size as the natural numbers, because the next set of numbers is called the whole numbers. So you may have heard that word before, and if you have, you're thinking, well, aren't whole numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., etc., etc.? Well, yes, they are. They add one and only one number to the natural numbers. The whole numbers are natural numbers plus 0. So 0, 1, 2, 3, etc. So the same set of numbers, but just a little bit bigger, right? So there's our next kind of layer of our amoeba. Whoa. They do all fit. Now, you notice as we're starting, you're going to see this bigger and bigger as we grow bigger and bigger. All of the natural numbers are also inside the whole number part, right? And that's intentional. There's a reason why we're drawing it that way, is because every natural number is also a whole number. And this is going to be true as we grow our amoeba bigger and bigger. With a new little addition here, which may be the first new thing in this course, possibly. Okay, so the next set on top of that are the integers, which is pronounced integers, not integers. But there it is, integers. So what are integers? You probably, hopefully, in your pre-algebra course or other middle school classes, you probably learned about integers, because integers are the same as the whole numbers, right? But it also gets negatives, right? So -2, -1, 0, 1, 2, and etc. in both directions, right? So it's positive and negative whole numbers are the integers. Okay. So that's our next set in this crazy amoeba. Amoeba. You know why we make it an amoeba? Well, no. You can figure it out. Let me know in the comments why I'm making it an amoeba instead of making it pretty. It is pretty. It's beautiful. It's fun. It's great. Right. The next set on top of that is that also includes inside of it the integers is the rational numbers. Rational numbers. Rational numbers are anything that can be written as a fraction, right? So it also is all the integers. So it's things like 1/2 or negative 0.18 or 52% or 3. Now, 3, of course, is also a integer, and it's also a whole number. It's also a natural number. Every natural number is also a rational number, but not every rational number is a natural number. That's why it goes in this direction. Because 1/2 is rational, right? But it's not a natural number. But 3 is a natural number, a whole number, an integer, and a rational number. Okay, now everything that we've had so far kind of builds on one on top of the other. And now I keep going down here. You can't see what I'm saying. But up here where you can see my face, they kind of grow. Now, there's another set of numbers that is not rational numbers. Now, this is going to be probably, if there's anything new in this video, this will be it. So this is where we kind of add from what we've seen in pre-algebra and before. And that is there's a set out here that is on its own. And that is the irrational numbers. Irrational numbers. Irrational numbers. So I said, and I don't know if you remember from a few seconds ago, but rational numbers are anything that can be written as a fraction, right? Irrational numbers are non-repeating, non-ending decimals. So numbers that cannot be written as a ratio of whole numbers, right? A ratio of integers or whatever, right? So they are things like the square root of 5. If you have a calculator handy, punch the square root of 5 on there if you know where your square root button is. On some of your calculators, you'll hit 5 and then the square root button. If you have a cell phone calculator, that's probably how you do it. So other calculators, you hit square root and then you hit 5 and you push enter, right? And you'll get this, right? You'll get this huge thing. You'll get 2 point blah, right? And that number is a decimal number that never ends, and it never repeats. I didn't include in the rational numbers. We should go ahead and add in here. So something like 0.6 repeating is a rational number because you can write 0.6 as a fraction. You can write it as 2/3, right? Excuse me. Because repeating decimals can be written as fractions, but non-ending, non-repeating ones. So things like square root of 5. Another really probably the most famous irrational number is pi. Everybody probably knows 3.14 or 3.14159, or if you're like one of my former students, you have it out to 50 decimal places. But that number, it never ends. Same way. There's another one that's you probably never heard of and probably aren't going to hear of, except maybe in like pre-cal or if you take calculus in high school. But Euler's number, which we represent with an E, is also irrational. Now, it's worth noting, and we're going to put an example of, you can have negative irrational numbers. So something like negative square root of 2, right? That's also an irrational number. Now, irrational numbers, they do not intersect and overlap with these others. So an irrational number can't be a rational number, and a rational number cannot be an irrational number. So those are all the types of numbers. Now, there is one big superset. It's the name of this video, but you've already figured it out. One big superset that includes all of these all together, everything, and that is the real numbers. Real numbers. You think, you're like, real numbers? No. So are there fake numbers? No, but there are imaginary numbers, which we'll learn about later in this course, at least a little tiny bit. And real numbers include everything except the imaginary numbers. So that is all the numbers that fit in all these different sets of numbers. That's the bulk of this video. We're going to take like half a second real quick, really quick to kind of remind you of something. Talking about, we mentioned square roots. We're going to throw this in here because the textbook I'm using puts this in this thing, and it's a fine place to put it. And that is with square roots. If we have the square root of a fraction, so let's call it a over b, that's the same as the square root of a over the square root of b. So a quick, super quick example, and we're only going to do one of these because we'll see a lot more of this later, or quite a bit. If we have the square root of 4/25, the square root of 4 is 2, and the square root of 25 is 5. So there we go. One down, a whole bunch more to go. Thank you for joining me. If you're one of my students, I'll see you in class. Don't forget to do your homeworks and all the things. Let me know if you have questions and all of that great stuff. If you're just joining us on the interwebs and you're not one of my students, thanks for being here. And no matter who you are, I really appreciate it if you hit that like button and subscribe button, and let us know in the comments what other types of videos about math or science or homeschooling in general we can help you out with. Thank you guys, and have a wonderful day. Bye-bye.